In this video, we're analyzing a vertical free fall problem. So we're told that we drop a rock starting from rest at the top of a very tall cliff, and we're interested in finding out how long it takes before that rock is moving 25 meters per second downward. In the follow-up question, we're going to find out how far the rock has fallen by the time it gets to that speed. And this is one problem where I feel like a downward pointing coordinate system is probably the most natural approach. You don't have to do it this way. But I'm going to set it up to say that the initial position is 0 and that down is the positive direction. So there's just a little reminder of what our origin of coordinates is. We're going to put that at the initial position of the rock, and I've put an arrow pointing down indicating that's going to be the positive direction as this thing falls. So that means we're going to consider the velocity to be positive at all times, and the acceleration caused by gravity will also be positive. So to answer question A, how long does it take before the rock is moving downward at 25 meters per second? Well, we know how fast it's accelerating, and we know its initial velocity, and we know its final velocity. So we can quickly relate all these things with our second standard kinematics equation. And that's just V equals V naught plus AT, where V stands for the final velocity. So we can just go ahead and plug in our 25 meters per second. Our initial velocity was 0 because we were told this thing started from rest. And our acceleration is positive, again, because we're using a downward coordinate system, positive 9.8 meters per second squared. And t is the only unknown there. So t is just 25 over 9.8. And we arrive at a time of 2.55 seconds. Now in part B, we want to find the distance that the rock has fallen during this amount of time. And we can actually go back to our first standard kinematics equation for this. We know the acceleration, we know the initial velocity, we know the time it's been falling. So I have x equals x naught plus v naught t plus 1/2 at squared. And again, we're using a downward pointing coordinate system here. There's no problem with that. My initial position I called 0. My initial velocity was 0 because I released it from rest. And this simplifies to just 1/2 at squared. Well, a is positive 9.8 meters per second squared. And the amount of time this thing has been falling for, we just calculated that, is 2.55 seconds. And don't forget to square that guy. And we arrive at a distance of about 31.9 meters. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.